Do you remember in physics class, staring at equations like these and wondering, what does this have to do with my life? So many of us memorized them, studied them for exams, and forgot them the moment we left the classroom. But what if I tell you, those equations are quietly running the world you live in, from the mobile phones in your hand to the satellites above your head? They all work using the equations we once thought. What does this have to do with my life? Those equations were never just homework. They are the blueprint of the universe itself. Welcome to Beyond the Equation, where we find out the stories behind the formulas and understand their real-world applications. Newton's law of universal gravitation, one of the first equations we found at high school physics. Multiply g by the two masses and divide the square of the distance, and you'll find the gravitational force. We memorized it, solved a few questions, passed the exam. But have you ever wondered what this equation does in the real world? Every time a rocket or satellite launches into space, engineers don't just point it toward the sky and launch it. They use Newton's law of universal gravitation to calculate Earth's gravitational pull. They calculate how strong gravity will be at different altitudes, how much thrust the rocket needs to overcome that pull, and exactly how fast it must travel to reach its orbit. If the calculations are wrong by even a small amount, the satellite could fall back to Earth or drift into deep space. But when the numbers are right, the satellite settles into its orbit, circling our planet thousands of kilometers, enable global communication, and help scientists study our planet. Newton discovered something extraordinary. He realized that every object with mass attracts every other object. The larger the mass, stronger the gravitational pull. That idea explains why an apple falls to the ground, why the moon keeps orbiting the Earth, and why our solar system has remained stable for billions of years. Without this equation, we couldn't calculate satellite orbits. GPS wouldn't know where you are. Space exploration would be almost impossible. One equation that many of us first saw on a classroom whiteboard is actually one of the foundations of modern civilization. So next time you see Newton's law of universal gravitation, don't just see another physics equation. See the invisible force that keeps the moon in orbit, guides satellites through space, and helps us to understand the universe itself.